So let's take a look at this warm-up. All right. Just looking for F prime. Really big use of the chain rule right here. All right. There's a lot happening inside this bad boy. And so if we look at this one, let's see, our outside function, we get 4 times that whole parenthesis to the third, okay? Times, then we're going to do the derivative of the inside stuff. And so if I do the derivative of e to the 3x, that would be e to the 3x, derivative of 3x would be 3, so it's going to give me 3e to the 3x. Plus, and then sine of 2x, that would be cosine of 2x. And then I'd have to multiply that by 2, derivative of the 2x. And so that leaves me with what, D? Okay, there we go. All right, so just repeated use of the chain rule. See what our affirmation is. The bad news is time flies. Good news, you're the pilot. But you see the coordination there? Yeah. I searched airplane in Canva, and that's what came up. Okay? All right. Good beat. Good times. All right. Unit 4, contextual applications of derivatives. All right. Straight line motion. What does it mean? Rates of change in applied context, related rates, local, that word, linearization and local linearity. Remember, that's just tangent lines. And then L'Hopital's rule. Okay, so we're going to kind of walk through several of these things and talk about all the different situations that show up. Then we're going to do some free response questions, and we'll do a few multiple choice as well. Okay, so related rates, they really like to throw in free response. Okay, here we go. Meaning of a derivative. All right, remember a derivative is an instantaneous rate of change, the slope of a tangent. It's just all kinds of good things. All right, get my favorite colors up here. Okay, so it tells us that C gives the cost of digging a hole X feet deep. So C at 20 equal to 140 means that a hole that is how deep?
20 feet.
Okay. 20 feet deep. Cost how much to dig? $140. Okay. So a hole that is 20 feet deep costs $140 to dig. All right, so now let's talk about the rate of change. Okay, so C prime at 20, all right, equals 5. So it means that when the hole is blank, the cost of digging is blank at a rate of blank. All right, so let's see if we can fill that in. When the hole is what? 20 feet deep. That's where the 20 comes in. The cost of digging, is it increasing or decreasing? Increasing. How do we know that?
Positive.
It's positive. All right, is increasing at a rate of $5 per foot. Okay, so getting those units correct, that's what that's looking at. Okay, so anytime we're interpreting units will be important. Okay, if I have a positive rate of change, then something is increasing. If I have a negative rate of change, something is decreasing. Okay, so just things to remember there. All right. Okay, there will be an interpretation question. Sometimes it will be in a free response, like one of the early parts. Other times it'll just be in a multiple choice. So you can see it both places. All right, so then let's jump to particle motion, linear motion. A particle moves back and forth on a horizontal track between time between 0 and pi over 2 minutes. Its position in feet is given by this function. It wants me to find the acceleration at pi over 6 minutes and then indicate units of measure. Okay, What's the relationship between position and acceleration?
Acceleration is the second derivative.
There you go. All right. I wrote that backwards. Hold on. Okay. So acceleration is S double prime. Velocity is S prime. Okay. So they are derivatives of each other. So looking at this problem, we're going to need to find the second derivative. Okay. So let's start with the first one. So velocity. All right. What's the derivative of tan?
Secant squared.
All right, so I have 1/2 secant squared t. All right. Now, for acceleration, all right, that secant squared, remember, could also be written like this: 1/2 secant of t, the whole thing squared. All right, so it's chain rule. All right, because I have a derivative formula for secant, I do not have one for secant squared. All right. So now, if we do this antiderivative, or not, do this derivative, 2 times 1/2, well, that would just be 1. Secant t is going to go to what power? 1. And then I'm also going to need to put a chain in there. What's the derivative of the inside stuff, which is secant? Secant tan. Okay. So it is chain rule, and you're going to have to do the derivative of that inside stuff. Now we want to evaluate A at pi over 6. And this is just going to be some really nice arithmetic. Okay. So I'm going to want the secant at pi over 6, and we're going to square it, times the tangent at pi over 6. Okay. I've got 2 secants there, so I'm just going to square them. All right. All right. Pi over 6, what's your ordered pair?
Square root of 3 over 2, 1/2.
Square root of 3 over 2 and a 1/2. Okay. Secant is the reciprocal of who? Cosine. Okay. So cosine is square root of 3 over 2. So secant is going to be 2 over the square root of 3, and we're going to square it. Okay. Tangent at pi over 6, all right, is going to be 1/2 divided by the square root of 3 over 2. Okay, 1/2 divided by the square root of 3 over 2. It's going to leave me with 1 over the square root of 3. And we're going to leave it like that. We do not need to rationalize. Okay, because if the 1/2's on the bottom, the 2's would cancel. When you divide fractions, keep, change, flip. Okay. And so now if we simplify, that's going to give me 4 over 3 times 1 over the square root of 3, which is just 4 over 3 square roots of 3. And we can leave it that way. Okay. If this were a free response question, okay, if this were a free response question, oh, not that. We could have left it right here at the pink, all right, where we'd evaluated. Okay, you would not have to work it out and get a final definitive answer. Right, so once you evaluate, you can leave it. Okay. So let's talk about a few other things that go with motion. How do we figure out if a motion is, or when motion stops from going left, right, or up, down? Where do we find a change in direction?
When velocity changes sign.
Yep, when velocity is equal to 0. Okay, so there's going to be a possible change in direction where v of t is equal to 0. We then look for it to change signs. Okay. All right, if it's positive velocity, then we are moving to the right or up. And then negative velocity means that we're moving left or down. All right, so some things about motion. How do we know when it's speeding up or down? That comes from a comparison. You actually have to look at 2 things. Okay, v of t and a of t have the same sign. Then we speed up. Okay, v of t and a of t have opposing signs, so they're different signs. Then we are slowing down. Right? So those are our main things about linear motion. I did a new mix today. Berry Blast Pina Colada. Excellent. There's a lot going on in there, but it's good. It's kind of a flavor explosion on your tongue. Oh, y'all, time is moving so quickly. Do you feel it? It's coming quick. Lots of exciting things. If you turned in your green senior sheets, you need to get those turned in. They're very important. Okay. Trying to stay on top of you about that.
Are you allowed to change it after you turn it in?
Yes. I would say yes. I mean, if something changes, you could go and add or subtract, whatever. All right, so let's look at this next question. All right, talking about other rates of change. And now that we've covered everything through integration, this question's a lot easier than it would have been if we just embraced it for the first time. Okay, so it says if P of t models the size of a population at any time greater than 0, which of the following differential equations describes linear growth, which describes exponential? All right, so let's think about that for a second. All right, what would be true about the slope of a linear function? It's constant, okay? Which one of these things is a constant slope? It is just, it's the first one, yep, equals 200. There's no variable change. This is linear, okay? We have a constant slope, okay? So a linear function or linear growth would show a constant slope. How would you know if it was linear decay? It'd be a negative slope, okay? So don't let them use tricky words like that and like freak you out. Just think about what we know would be true. If it's decreasing linearly, then I would have a negative slope, okay? Now, exponential growth, all right? We didn't talk about that until we got to integrals, all right? But how do we show exponential growth? Do you remember? Nope, that would be the easiest answer, right?
It's the number to x, right? To the power of x?
No. Think of it in a slope form. It's direct variation. Okay? Again, remember when we solved all those differential equations? Remember dy dt would equal kt. Okay? Or, no, anyway. And we would solve it. So, which one of them shows me, actually this would be p, or hold on, varies directly with y. All right. So which one of the three up there shows that direct variation? We've got two options, right? We've got this one and we've got this one, okay? It varies directly with y, which would be the variable on top. Which variable was on top in our differential equation? Yeah, the p. So this is the one that we're looking for exponential growth. Direct variation. It's going to be a constant times whatever variable you're differentiating in the top, okay, on the other side. Exponential growth is direct variation. Right. With other rates of change, they could still ask you questions about when is it increasing, when is it decreasing, my rate going in, my rate coming out. Like there's all those kind of questions fall in that in terms of other rates of change. And we apply it just like we do with motion, okay? Just like when we did accumulated change, right? If we knew this was my starting position and then I'm going to accumulate this much, we could do it that way as well. All right, and then we got to related rates, what we all love to hate, okay? It's where the geometry came in. The good news is they're pretty good about giving you the geometric formulas now. They used to not do that, and so I'm glad now they include that in the question stem. But let's just start with a basic one, all right? It asks me to determine dz dt if we know that z is equal to x, y squared, and then it gives me a bunch of values, okay? Notice that it gives you a rate of change with respect to time for x and y. That means everything is implicit, okay? Everything is going to get some kind of rate of change next to it. So if we take this expression, or this equation, z equals x, y to the second, let's differentiate that entire thing. What would be the derivative of just z? dz dt, okay? On the other side, we have a product rule, okay? So first, times derivative of the second. Derivative of y squared is going to be 2y dy dt plus second times derivative of the first. Derivative of x would just be my dx dt. Right? Now we substitute and solve. So let's see what we know. We know z is 3. Didn't need it. We know y is 1/2. So I have x times 2 times 1/2. I know dy dt is 5 plus 1/2 squared. Dx dt I know is -2. Okay, so I'm still missing x, and I'm trying to find dz dt. What could I do to find x? Yeah, plug in z and y to the original equation and solve for x. Okay, so if I know z is 3, that equals x times 1/2 squared, or 3 equals x times a 4th, where my x is going to equal 12. Bless you. All right, so 59.5. So that was kind of that introduction to related rates. We took derivatives with respect to time. All right, and we're going to do a good free response example here in a second with shapes and all that good stuff. Yay! One of my nephew's little friends came to visit from school, came to visit him last night at the hospital. And then today was their house party, so he wore, instead of wearing his house colors, he wore Eli's house colors, which was really sweet. But now he's having what they call delirium from the high-dose steroids, so it's kind of pitiful.
How old is he?
He's 10. He's 10.
You said they were supposed to get the MRIs.
Yes, he has, did I tell you he has 2 lesions on his spine? Yeah, so they found 2 lesions at the top of his spine. And they're considering 3 things. I have to look them up. NMO, that's an autoimmune something, that's the worst one. MOG, that would be the best option. And then it's also autoimmune, and then multiple sclerosis. So those are the 3 things they're trying to figure out. They said, you know, the doctor's like, she goes, if I was, you know, could lay money on it, I'd say it's the middle one, which is the best one. But they're still having just to collect a lot of data and figure it all out. And he's bored out of his mind. 10 in a hospital. He rode the scooter around the hallway last night forever. His siblings played hooky yesterday, the 2 that are at home, and came and spent the day with him, so that was good. But then, like, he was asleep, like, out at, like, 8 o'clock last night because he was so tired. But anyway, and then the twins who are at Lee in Cleveland, Tennessee, are coming to our house for Easter weekend. So they'll be here this weekend, so we'll get to kind of love on them. But the siblings are struggling not being able to be with him all the time. And then, you know, the older two, their parents aren't at home, you know, so it's just a lot. So, but anyway, it's sweet. People have been very, very kind to them. So, go ahead. Good. Okay. So let's jump over here and let's talk about tangent line approximations. This is that tangent line problem we've been doing since we started limits. Okay, like it doesn't change, but there are some things that will help us with these, or things that they could ask us about. Okay, the thing to remember that if it ever asks for a linearization, that is a tangent line. Okay. So I said when we started calculus, we'll do about 10 things, we'll do about 5 things, but call it 13 different things. This is one of those examples, okay? They put a new vocab term in there just to say, hey, find a tangent line, right? So let's see what they tell me. G of x is differentiable, and about which little else is known other than g at negative 3 is 2, and g prime at negative 3 is 7, right? So first thing it says to do is to use a tangent line. Well, let's write that equation. To write a tangent line, remember we need a point and a slope. Did they give me those two things? They sure did, okay? The point they gave me was negative 3 comma 2, and the slope they gave me was what? 7, right? So let's write that equation. Y is going to equal 7 times x plus 3 and then plus 2, okay? Then it asks me to do the next step. So you would probably get a point for that equation, all right, in a free response question. It wants me to approximate negative 2.9, and this most likely will be on a non-calculator, all right, just as a heads up. So if we're going to approximate g at negative 2.9, that's going to basically be my tangent line evaluated at negative 2.9. Okay, and that's what we'll use to do that, okay? And so negative 2.9 and 3, the difference between that is a positive 0.1 plus 7, so I get 0.7 plus 2, which is 2.7, okay? It's 2.7, so not intended to be difficult, all right? The only other thing they will ask me to do in regards to linearization are overestimates and underestimates, okay? Both of those come from concavity, right? If my function is concave down, then my tangent line would be over the top, right? So if it's concave down, my tangent line approximation would be above it, so it would be an overestimate. So you have to know about concavity, right, to determine over and under. An underestimate, it would be concave up. And if we think about the curve, if I could hold water and I throw a tangent line in there, it would be below the actual value of the curve. Okay, so underestimate. So that's just one of those things. Okay, over and underestimates come from concavity. And I just have to visualize that. As long as I remember it comes from concavity, I think about what I have at that point and go there. Okay, so the pink is the actual f of x. All right, so if this was g of x, the pink. The function itself is below my approximation line. So my approximation line is an overestimate. It's above, all right? All right. And then that, because this was our shortest unit we did, it brought us to L'Hopital. All right, L Hospital. All right, good old L Hospital. And remember, in order for L Hospital to work, okay, your limit must be indeterminate. Right, 0 over 0. Or infinity over infinity, but most of them you're going to see are 0 over 0. Okay, we must show. All right, so you must show. All right, limit as x approaches whatever value they give you. So I'm going to say a of The top being f, let's call it n of x for numerator. So that reminds me that we're looking at a rational function. Okay, of n of x is equal to 0, and the limit as x approaches a of the denominator is equal to 0. You have to show that. You can write it as a sandwich, remember. Okay, you can say limit as x approaches a of the top equals 0 equals limit as x approaches a of the denominator. But you have to state that in a free response. Okay, if you don't, they will not give you credit for using L'Hopital. All right. If that is true, then we can take that limit of n of x over d of x is the same as the limit as x approaches a of n prime over d prime. Okay, so we can use derivatives to evaluate the limit. And sometimes we have to use it repeatedly. Okay, we'll have to use it repeatedly. If you can do it once, you can do it infinite times. Okay, so that's one of the nice things. You only have to show the 0 sandwich once. All right, because then L'Hopital continues to apply, and we can use it. Okay. I'm going to give you 4 tonight where you use L'Hopital. All right, so you can practice that. But it's pretty straightforward. All right. Remember, L'Hopital also works on those algebraic ones where we need to simplify, and if you get stuck and you're like, my brain can't factor today, then you can use L'Hopital. It works. Okay. All right, so let's check this one. If I plug 5 in, 5 to the 4th is 625, so that would be 0. 5 squared minus 25, that would be 0. So here's what we would write to start. Limit as x approaches 5 of x to the 4th minus 625 equals 0, and that also equals that bottom limit, x squared minus 25. So that's my 0 sandwich that we have to write. Okay, the numerator, the denominator, both those limits have to equal 0. Okay, which then allows me to do this. Limit as x approaches 5. What's the derivative of the top? 4x cubed. Derivative of the denominator, 2x. Okay, now we want to evaluate this limit. Okay, direct substitution. All right, 4 times 5 cubed over 2 times 5. Well, the bottom's definitely 10. 125 times 4, that'd be 500. So my answer is 50. Okay. So that's the basics of what was in Unit 4. Let's get to the good stuff. Okay. Sucker time. Where I smack you in the face with a sucker. You know it's coming. Do you have a preference for snack for Saturday? Friday morning, sorry. I can do donuts. I could do sausage biscuits. I like it all, to be honest with you. Okay, we'll see. Muffins, I could do muffins. Got it. Okay, bring your own drink, though. Okay, BYOD. Okay, bring your own drink. All right. And Oakley, we would save you one, but it would kind of be gross after. Sorry, but you're going to be winning at Wilson Central. Yeah, you are. Yep.
No, that's not what
All right, let's take a look here. So a cylindrical barrel with a diameter of 2 feet contains collected rainwater as shown in the figure above. So this is actually from 2019, so it's pretty recent. Yeah, one day next week I think we're going to do the 2024 free response. I haven't decided which day yet, but
How was it?
I don't know. I didn't take the test, so I've not looked at them. Yeah, so we're going to all embrace them for the first time. We'll see what happens. Okay. It says the water drains out through a valve at the bottom of the barrel. The rate of change of the height of the water with respect to time is modeled by dH/dt equals negative 1 over 10 square root of h, where h is measured in feet, t is measured in seconds. The volume of a cylinder with radius r and height v is given by. So, they gave me that volume formula. Okay. Alrighty, so let's see what it wants me to find. Find the rate of change of the volume of the water in the barrel with respect to time when the height of the water is 4 feet, indicate units of measure. Okay, so let's think about our cylinder. It talks about a radius. So we're looking at this water. What would be the radius of my water? It would always be 1. Okay, so the radius is never going to change, and that's good news. All right, that cylinder is the same height, that barrel, is the same diameter the whole time. So when I'm looking at A, all right, when I think about my volume, pi times my radius, we know always is 1, and then h. Okay, so I can plug it in. If this was a cone, could I do that with the radius? No, because in a cone, remember, the radius changes. Okay, but in a cylinder, it stays the same. So my volume formula is pi h. Well, that's a lovely little formula. Okay, I want to find the rate of change of the volume. All right, so I'm looking for dv dt. So we're going to take the derivative with respect to time. What would be the derivative of just h? dh dt. Okay, so there is that piece. Okay, now we've got to figure out dv dt. They also, in all their infinite wisdom, gave me a formula for dh dt. So they didn't just tell me what it was. All right, so I can find dh dt. It's going to equal negative 1/10 times the square root. And what was h? 4. Okay, this is a non-calculator question. All right, this is number 4. So dh dt is going to equal negative 1 over 10 times 2, or negative 1/5. So dv dt is going to equal negative 1/5 pi. All right. So are we good with that? Now, it wants units for this. Okay. And let's talk about what it means. What would be this? Our height is measured in what? Feet. And our time was measured in seconds. So my units would be feet per second. But now let's talk about what that means. All right. What is happening to the volume when the height is 10? Or 4. Yep. So volume is, we've got negative there, decreasing at a rate. Now, once we say decreasing, I never have to think about that negative because decreasing means negative, okay? So if you said decreasing and a rate negative, that would be like a double negative. Does that make sense? Okay, decreasing at a rate. Oh, but it's not just feet. What is it?
Feet cubed.
Feet cubed. Thank you. I just saw it. Feet cubed per second. This is why I love y'all. Y'all, attention to detail. You do better than me sometimes. Takes a village. Okay? So, I was trying to see if I had my scoring guide. Hold on just a second. So I can tell you what they gave you points for. I don't, but I believe it was 2 points. You got one for the dv/dt and one for the units, the correct answer with units. Okay? All right, now let's look at B. Okay? Let's do part B. It says, when the height of the water is 3 feet, Is the rate of change of the height of the water with respect to time increasing or decreasing? Right? Is it increasing or decreasing? So we're talking about the rate of change of the height. So do I need this original related rate that we did? No, all I need is dH dt. Okay? So I need dH dt evaluated when h is equal to 3. Okay? And so if we plug that in, negative 1/10, negative 1/10 square root of 3. Now, that just gives me negative square root of 3 over 10. Okay? The height, what would be the units of measure for just the height? Feet per second. So the rate of change for the height would just be feet per second. So question, is the height, the rate of the height of the water, increasing or decreasing? Okay, so when we look at this one, all right, is the rate of change of the height with respect to time increasing or decreasing? All right, so at this point we would have to take a second derivative, okay, because this is like comparing acceleration and velocity. All right, if they're both positive, then it's speeding up. If they're both negative, then it's slowing down. All right, so we're going to have to take a second derivative. So let's do that. So d squared h dt squared. All right. So I have negative 1/10 times the square root of h. That would be h to the 1/2. Everybody agree with that? Okay. So that would give me negative 1 over 20. H is going to go to what power? Negative 1/2. It was a positive 1/2, so it goes to a negative 1/2. Okay, we subtract 1. So now if we evaluate that at 3, okay, so d squared h dt squared evaluated at h equals 3, I get negative 1 over 20 times 1 over the square root of 3. What's still true about this rate? It's still negative. Okay, and it would be feet per second squared, feet per second, all right? So now we can say that the rate of change of the height, okay, is it increasing or decreasing? All right, they're both negative. So that means, are they working together or against each other? Together, okay? Is increasing because dH dt and d squared h dt squared are both negative. Okay, so we have to talk about both of those things. All right, so that's kind of hidden in there. Mm-hmm.
So it's becoming increasingly negative.
Yes. Yep, they're working together. My original equation was dH dt equals negative 1/10 times h to the 1/2. So when I took 1/2 times negative 1/10, it gave me negative 120. Yeah, I just didn't rewrite it back down. Mm-hmm. Yeah. Okay. All right, let's look at this one. Okay, this is just part D on the 2018 test. All right, question 4, it too is non-calculator. Okay, so we're talking about a tree. Okay, we're talking about a tree. The height of a tree in meters can be modeled by the function g, given by g of x equals all that good stuff, where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. According to the model, what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? All right, let's go back and dissect what they told me. What does g of x represent? height of the tree. Okay, it is the height of the tree. X is the diameter of the base. Right? Okay. So I think 4, does it tell me? Yes. All right. When the tree is 50 meters tall, all right, so that's its height, the diameter increases at a rate of 0.03 meters per year. Okay. What's the rate of change of the height? So I'm looking for dg/dt because that's my height. At the time when the tree is 50 meters tall. All right, so when g of x equals 50. All right, that's what it's telling me, and that's a lot. Okay, that's a lot. So the first thing that I realize is it wants me to find dg/dt. So that's the function I'm going to mess with. Okay, but I'm probably going to need some other functions along the way. All right, but let's start there. Okay, so dg/dt is going to equal, all right, this is a quotient rule. Ho-de hi minus hi-de ho over ho-ho. Okay, so 1 plus x, derivative of the top is going to be 100 dx dt. Okay, plus hi d ho, all right, would be 1 dx dt, all over ho ho. Okay, everybody okay right there? All right, so I just took, that's what it wanted me to find, is dg dt.
Would it be minus?
Yes, it's minus, thank you. Thank you. Okay. All right. Now, this is where it gets interesting, right? Because we got to be able to fill all this stuff in, all right? They gave me dx dt, all right? They told me the diameter was increasing at a rate of 0.03 meters per year, all right? So I'm going to be able to replace the dx dt's, all right? What I can't replace yet is the x, okay, is the x. So let's figure out, how might we figure out what x is? They gave me one thing that's going to allow me to do it. Yeah, they told me that g of x was equal to 50, okay, at the time in question. So I'm going to say 50 equals 100x over 1 plus x, and I'm going to solve for x. Okay. I can cross multiply, so 50 plus 50x would equal 100x. 50 would equal 50x, or x would equal 1. Okay, that's my favorite number. I'm so glad they picked it. Okay, so now let's plug into dg dt. Okay, so I've got 1 plus 1 times 0.03 minus, I forgot my 100. 100 times 1 times 0.03 divided by 1 plus 1, the whole thing squared. Okay, now, free response, and I know this is going to sound crazy. You can stop right there. All right, you've plugged all that stuff in. It's a non-calculator question. You don't have to finish the arithmetic. Okay, what would your units be? Meters per year. Okay, and we could stop right there. Now, good mathematicians, I have to finish it. Okay, so 2 times 0.03 minus 100 times 0.03 over, that would be 4. So that would give me what? 0.6. 0.06. Minus 3 over 4. Negative 2.94 over 4. I don't know. Anyway, but you don't have to. All right, that's one of the nice things about that question. Somebody use a calculator and tell me what it is. Okay, 0.735.
Oh, negative.
Yep.
Disappeared for between the green and gold.
What did?
The 100.
Oh, you're right. Thank you. I was like, why did I get a negative? I kept thinking, there it is, Justin. I forgot that 100. Oh, that changes things. 6 minus 3 over 4. That's a lot better. Oh, highlighter. Which would be 3/4, which would be 0.75. That's better. Thanks, Justin. I lost my 100. Happens. Okay. I was like, if everything's increasing, why is that changing? The negative. Oh, makes sense. Okay. Appropriateness of answers. All right. So they're going to hide some things in those problems. Okay. The only way you get good at finding them is to do them. All right. So that's why I'm giving you one tonight to do. Okay. So you can practice along with the scoring. All right. The last few I want to do are multiple choice practice, and then we're going to be done. We've got 3 of those. Okay. So I want you to take a second and try that first one. This was not listed as calculator active, but I feel like it would be on the calculator active portion. So. All right, so this is a linearization question. All right, it tells me that g of 3 is 2 and g prime at 3 is negative 3/4, and it wants me to approximate g at 2.6. Okay, so we're going to use the tangent line to do that. So y is going to equal negative 3/4, x minus 3, and then plus 2. Okay, if we put 2.6 in there, okay, so negative 3/4 times 2.6 minus 3 plus a 2. All right, so it's going to give me negative 3/4 times 1 or 0.4 plus 2. Negative 0.4, appreciate you. All right, so that would be negative 3/4. Since I don't have a calculator, negative 4/10 plus 2. My 4s would cancel, and I would get negative 3/10 plus 2, or a 1.7. Okay, so you can do that one without a calculator. All right, you just don't like to. All right, 3/10 would be a negative 0.3. And then a positive 2, so I'd have 1.7 left. Okay, now the question becomes about over or underestimate, because if we look, I have 1.7 and I have 2.3. All right, so notice they put answers in there where if you did the arithmetic wrong, you would pick it. Okay, so they're going to put those in there. They make the most common mistakes, and those are the answer choices. So you feel super confident. You're like, oh, my answers were there, but you might have did all the common mistakes. Okay, so it's not like ACT where you can be like, it's closest. Check. All right, so here we go. So we know it's got to be one of the first two. All right, they tell me that this graph is concave down. Okay, if it's concave down, do I have an over or an underestimate? I have an over. My pen's just quit writing. So that would give me B. Yep, it would be B. Question on that one. Did I do something wrong?
Don't the negatives cancel out?
Yes. God bless America. Y'all keep looking at me, and I'm like, what is going on? My pen didn't charge last night. That's a bad sign. Okay, yeah, it's going to be 2.3. All right, and so it would still be an overestimate. No, underestimate, because, no, the approximation would be over because it's above it, right? It's concave down, so it'd be an overestimate C. Okay, my writing's about to get terrible, just so you're aware, because I've got to use this. Okay? All right, here we go. Look at this one. All right, let's look at this one. I think this one's a little bit confusing just in terms of how it's set up, okay? This is a particle traveling on the x-axis has position x of t at time t. The graph of the particle's velocity is shown above. So this is v at t, okay? That's v. Ooh, writes really big. All right, so that's v at t. So if we're thinking about this one, we want to know the total distance traveled from 0 to 5, okay? What's going to be true about all of this distance that is above 3? It's positive. What about the distance below 3? It's negative. And so, but I could do the absolute value, add them together, I would still get positive distance, okay? So we for sure need to go from 0 to 3, all right? So we've got to go from 0 to 3, all right? But then we've also got to consider the distance from 3 to 5. All right. If I want it to be positive, what are we going to have to do?
Subtract.
Yeah. Okay. So we're going to have to subtract. Well, notice they didn't subtract in the middle. All right. Which would have been the nicest thing they could have done for me. All right. Was to subtract that negative distance. Okay. But they didn't do that. All right. So what would fix that? Anybody know? Switch them. Okay. Switch them. And so if we switch them, which one should I choose for the second piece? C. Okay, so C is my correct answer. And that's weird, all right? That's just a weird way to think about that. Most times when you see total distance questions, they're going to be in terms of integration, all right? But here's where they gave you one in terms of position. And so in order to make this position positive, or make that distance positive, we have to switch the order that we did it in. Usually we would do 5 minus 3. Okay, so we did 3 minus 5 to switch that because they didn't subtract in the middle. All right, so just weird right there. Okay. All right, let's do one more. Okay. Take a look at that one. All right, sorry, my writing's terrible. We're going to have to take velocity on this one. If we want to know where it's farthest to the right, we've got to think about when is it switching its location, okay? And so this is a product derivative. So I take first t, derivative of the second, e to the negative at, times derivative of that exponent would be a negative a. So that's weird looking. Plus second, e to the negative at, times derivative of t, which is 1, all right? Simplify all that out. I can pull an e to the negative at out of both of those, all right? And the reason I want to do that is because is that ever going to equal 0? No, okay? An e function never equals 0, all right? So what I really am concerned about is that second piece. Where does that equal 0? Where does negative at plus 1 equal 0, right? That's my turning point. If we solve for t, t is going to equal 1 over a, right? It's the only place it's going to turn, right? So that's important. We could go ahead because that point's there and say, oh, it has to be that because it's the only place it turns. But we need to know which way does it go. Is it going right? Is it going left? Because it says we start greater than or equal to 0. Okay, so we're going to start at 0. We're going to do our sign chart, and we're going to put 1 over a in there. Right? And we want to try to figure out, is it going right or left? Okay, so v of t, is it positive or negative? Now, this is a crazy question, right? What would be a value between 0 and 1 over a? One over 2a, okay? 1 over 2a, that would work. Okay, 1 over 2a. The only part I have to put it in is right here, okay? If I put 1 over 2a into that, okay, that's going to give me 1 over 2a times a negative a, okay, or a negative 1/2 plus 1. Is it positive or negative? Negative 1/2 plus 1. It's positive, so I would go right, and that's what we're looking for. Since this is the only place it turns, it's going left afterwards, so where is it farthest to the right? At 1 over a. Okay. If you weren't sure how to progress after you found that one turning point, that's a safe answer if you didn't know where else to go. Okay? Not guaranteed to be accurate, but it would, if you didn't know anything else to do, that would be a safe answer. Okay?
If it had a negative instead of a positive.
Yes, then it would be 0. Yep.
Because that's its chart. Okay.
Yep. Yep. Okay? All right, good job. So, let me give you a wrap up. I've got FRQs for you to do today. There's just 2 of them. 3, I lied. FRQ practice and a L'Hopital. Okay? And then let's do the wrap up.
What is that last topic called that we just did a question on?
Linear motion. Nice. And then on Google form.
We should get those videos.
Yes. All right, I forgot somebody. Solomon. You got one?
Maybe it's just
No, I
a
didn't.
Sunday. Maybe it's just a Sunday you have to do it.
Maybe you forgot me.
No?